Hello students, now in this chapter we are mainly concerned with the semiconductors. So now we will discuss only about the semiconductors. Types of semiconductors. Now there are two types of semiconductors. Two types of semiconductors. Number one, the intrinsic or pure or undoped semiconductors. And second is extrinsic or impure or doped semiconductors. So here we will take the intrinsic semiconductors. Doped will be discussed later on. The main purpose of this is to increase the electrical conductivity of the semiconductors. So how can we increase the conductivity of these elements? Because they are widely used in electronic devices. So we have to understand their activity. So first I am taking the intrinsic semiconductor. Intrinsic semiconductor. They are tetravalent elements present in fourth group of periodic table. So now we have this silicon and silicon Si. Now Z equal to 14. So now we can divide the electronic configuration. This is 2, 8 and 4. Or we can have this 1s2, 2s2, 2p6, or this 3s2, 3p2. This is like this the electronic configuration. Germanium. Germanium, Ge, Z equal to 32. So electronic configuration, this is now 2, 8, 18 and 4. So now we have this 1s2, 2s2, 2p6, then this is now 3s2, 3p6 and 3d10, and this is now your 4s2, 4p2. So in the last orbit we are having the 4 electrons. So this is why that they are tetravalent elements, and moreover the energy gap of this here is also small. So all these 4 electrons in the outermost orbit make a covalent bond. So they have tetragonal structure. Silicon and germanium have tetragonal structure. So this is like this, that suppose these are the silicon atoms or the germanium atoms, and they are having this the germanium or silicon element is present in either of the corner of this triangle. This one, then this will have again the tetragonal, whether this is here, then again this has the tetragonal structure. So thus there is a tetragonal structure of the germanium and silicon crystals. The 4 electrons in outermost orbit of germanium or silicon make covalent bonds with 4 nearest atoms. Because every element wants to have the 8 electrons, they want to have the complete octet. So for octet there are 4 electrons and we need 4 electron more, so there will be the formation of the octet, and this will happen only when there is the formation of the bond, and this bond is the covalent bond. So every germanium or silicon atom makes the covalent bond with the 4 nearest atoms. Make covalent bond with 4 nearest atoms. So here it is like this. Let's suppose this is a Then this is the electron. Similarly, these form the covalent bond with other I show you it to be here. These are the electrons. This will make two other atoms the covalent bonds. So thus this process goes on. And you can have that, this is suppose your germanium. This is germanium atoms I have shown you. Like this. I have shown you the germanium crystal. This is the germanium crystal. And this structure is at 0K temperature. Equal to 0K. So it means that at 0K temperature there is no free electron and all the electrons are engaged to form the covalent bond. So the electrical conductivity of these crystals at 0K is always 0. At 0K there is no free electron in the crystal says all atoms make covalent bonds with each other. One answer. So the electrical conductivity is 0. Resistance is equal to infinite. Infinite. And electrical conductivity is 0. So we can say that at 0K all these semiconductors behave like a insulator. Thus at 0K all semiconductors are perfect insulators. But since all the crystals are present at the room temperature, so they have the thermal energy, and because of that some of the covalent bonds are broken at room temperature. Some covalent bonds break down to make the electrons free, and these electrons go to conduction band where they are free. When a covalent bond breaks a hole, a vacancy, or hole is created, which behaves like a positive charge. So charge on the hole is equal to plus 1.6 10 raised to the power minus 19 coulomb. So thus the electron and holes are created. The hole so created is filled up by the nearest electron, which again makes a vacancy. this process continues. So electrons and holes are formed. Thus, due to thermal energy, the covalent bonds breaks and there are electrons and holes. The holes are always found in the valence band. The holes are in valence band. So the number of holes is equal to the number of electrons. Both are in the same amount. Let n equal to number of holes, number of electrons, and p equal to number of holes, and this n equal to p equal to ni. Ni is called the intrinsic charge carrier, where ni intrinsic charge carrier. Number of intrinsic charge carrier. So these are all equal. So we can have this n into p is equal to ni square. This is the law of mass action. Now when temperature is increased, when temperature is increased, the number of electrons and holes increases exponentially. As given by the following relation. Ni equal to 8 t to the power 3 by 2 on this e to the power minus delta Eg upon 2 kT. Where delta Eg is the band gap, K Boltzmann constant. Boltzmann constant, and T the temperature. So you can see from this relation that as the temperature increases, the charge carriers, the intrinsic charge carriers increases at a very high rate. So if we have this, suppose we have this Ni, and this we have the temperature T, then you can find that they increase like this. So thus they increases to a very high value. Thus the number of charge carriers depends upon the nature of the substance and the temperature of the crystal. So this is what the intrinsic charge carriers, the intrinsic semiconductors. So these are the pure semiconductors in which there is no impurity at all. And now next day I will tell you the extrinsic semiconductors. So thus we see that the intrinsic semiconductors have the very low electrical conductivity because the temperature cannot be increased to a large value, and when it reaches to the melting point, then whole of this crystal is destroyed and no meaning of to study its electrical conductivity. So our aim will be that without increasing the temperature, how can we increase the electrical conductivity of the intrinsic semiconductor? That type of semiconductors are called the extrinsic semiconductor. That we will discuss later on. So you like, share, subscribe this video. Thank you.